Welcome to XphereLab. In this demonstration video, we will show you how our modules and tools transform complex data into strategic information for decision-making. Let's begin with the first dataset from the coast of Acapulco, Mexico, captured with the Leica Geosystem CityMapper 2. We are visualizing the project's three-dimensional model. The platform provides an optimized rendering environment that enables smooth and stable exploration of large data volumes, ensuring high performance and visualization accuracy. Virtual tours can be conducted directly from the browser. Access is managed through username and password authentication, with no need for additional software installation, facilitating deployment and cross-platform accessibility. In the next step, we are displaying the LiDAR point cloud from the layer visualization panel on the left. We have developed a proprietary methodology that integrates advanced data transformation, structuring, and compression processes, together with cloud resource optimization, enabling efficient visualization of high-density point clouds even on mobile devices, without compromising performance or data quality. The dataset also incorporates high-resolution orthophotos, fully georeferenced and aligned with the LiDAR information, facilitating integrated analysis and cross-validation. Additionally, terrestrial capture data is integrated within the same project. We are visualizing the terrestrial laser scanning acquired with the Leica Geosystem TRK500 EVO system, which provides high-precision information at urban detail level. The environment also incorporates 360 panoramic images, georeferenced and spatially linked to the model, enabling immersive visual inspection. Likewise, Google Street View is integrated as a complementary historical reference source, facilitating multitemporal analysis and the identification of territorial changes. Regarding automatic object extraction through computer vision, the platform enables automated object detection. Streetlights, in this case, as one of the most representative use cases. Two elements have been detected. However, the system can identify any type of object through configuration and training with different knowledge bases. Additionally, the platform allows the upload and integration of two-dimensional data layers, fully interoperable with the three-dimensional environment. We directly request the creation of buffers. On screen, we see the summary results chart. From this integration, advanced geospatial queries can be executed. These queries can be generated typing in the top bar or through voice commands. XphereLab interprets natural language instructions, facilitating interactions even for users without specialized technical training. This capability is particularly useful for identifying and classifying elements, such as tree cover and land cover analysis in this case. We are asking XphereLab how many trees are located within a specific coverage area. The exercise returns the identification of 5,822 trees. The records are automatically structured for further analysis. All queries can be exported and stored. In a second case, we demonstrate how XphereLab can incorporate information directly from web-based geographic services, so we can analyze official or open data in real time without local downloading. We select the service type, WMS. Enter the service URL. Choose the layer of interest, and then we display the information. In this opportunity, we are displaying the high-resolution orthophoto of the city of Bogotá, Colombia, captured in 2020 during the pandemic using the Leica Geosystem DMC3 large format sensor. In this third case, within a municipality in Colombia, we observe the territory from a different perspective. XphereLab unifies 2D, 3D, and 360 data, creating an environment where engineers and citizens can explore information clearly and intuitively. From 3D models to LiDAR point clouds, every input enhances the platform's analytical potential. This case illustrates the platform's applications in cadastral updating, enabling revenue authorities to query outstanding property tax portfolios and obtain immediate responses in tables or charts. In this municipality, the total outstanding debt is shown on screen. Now, if we ask XphereLab to list the top 500 properties with the highest property tax debt, the requested information becomes available for export in Excel format. We effectively obtain 500 records. Next, we are viewing the same geospatial query distributed by neighborhoods. We can generate a map showing the spatial distribution of debt, helping focus collection efforts where they are most needed. In this case, the neighborhood with the most critical situation is Parques del Muña. We just generated a map with the spatial distribution of the information. The true advantage lies in the ability to cross-reference data from different sources. For example, we can analyze properties located in a flood hazard zone or perform geospatial queries focused on areas of interest, either imported as geographic files or drawn directly on the map. As a complement, analyzed information and findings can be extracted and shared, facilitating decision-making. In this case, rivers and drainage networks intersecting an area of interest are extracted and downloaded as a shapefile. Next, we display additional thematic hazard maps derived from the open municipal information. Thematic map, fire hazard. Thematic map, mass movement hazard. Demonstrating how data is transformed into actionable knowledge. XphereLab's artificial intelligence agents evaluate multiple variables of interest. They integrate information from diverse sources to enrich the knowledge base. In this example, automated detection of construction typologies is being performed, describing facades, materials, and number of floors. A task that typically requires extensive fieldwork can now be executed automatically, maintaining a standardized and consistent criteria as a human expert would. The agent also analyzes outdoor advertising, signs, and billboards, too, in this construction, evaluating dimensions, text, images, and location, even reading text with greater precision than the human eye. Based on this information, automated regulatory compliance assessments are generated. In this case, the agent detects that the building does not comply with the current regulations and provides specific recommendations, such as reducing to a single advertising element per facade. XphereLab generates automated reports that can be shared directly with decision makers. Geostatistical analysis and interactive charts provide a dynamic way to understand data and quickly detect patterns. On screen, building classification map by number of floors. Land use map. Multidimensional poverty map. The street light module operates on both the point cloud and the panoramic imagery. Here we can observe the implementation of the module across the entire municipality, achieving a comprehensive public lighting inventory. This facilitates planning, maintenance, and data-driven decision-making. In this fourth infrastructure assessment case, we highlight XphereLab's geometric measurement module. We can calculate height, distance, or area directly on the LiDAR point cloud. These geometric measurements are highly reliable and can be obtained within seconds as a preliminary project assessment. Working directly with the point cloud keeps all information centralized and accessible from any location. In that way, engineers and technicians will perform complex analysis immediately. The fifth case presented applies to mining project monitoring. These type of projects are highly dynamic, evolving daily, and generating large volumes of information. This requires efficient visualization and analysis solutions. For example, parapet analysis in XphereLab can be completed in under 10 seconds. And the entire operations team can securely access the results through an authentication and permissions system, promoting teamwork, consistency, and real-time collaboration. Let us observe how on-site monitoring can be conducted using panoramic images. Finally, let's look at one last environmental assessment case. Through XphereLab's access to Colombia's historical deforestation layers, viability analysis can be performed to support compensatory reforestation processes. The platform enables intelligent prioritization of resources for greater impact. The visualization of critical hotspots over the past 10 years provides actionable analysis. The territories with the highest deforestation rates in Colombia are the departments of Caquetá, Meta, and Guaviare. This concludes the demonstration, highlighting the comprehensive value of XphereLab, a platform that combines complex data, advanced analytics, and collaborative tools to support strategic planning and data-driven decision-making based on reliable, real-world information.